Good afternoon. Today we are going to see now the solution of the exercise 2 part 2. Now the principal stresses at a point are 150 MPa tensile and 75 MPa compressive. Try to understand when they are mentioning over here principal stresses means tau on this is 0. And so if we will draw the diagram, then we have diagram in this fashion. So we have given 150 tensile. So we have this as 150 tensile. So both sides we have same 150 tensile. Second is given 75 compressive. So we have 75 compressive. MPa. Now we have to find resultant stress in magnitude and direction on a plane inclined at 60 degree to the axis of major principal stress. So we have drawn axis and it is making angle. So it is horizontal. So making angle 60 degree. So it will be our value theta. So we have this with vertical. So now write given data. So given data. You have sigma x plus 150 because it is tensile. You have sigma y minus 75 because it is compression. Theta we have clockwise. So theta is 30 degrees. And then we have to find sigma n because sigma r is root of sigma n square plus sigma r square. So sigma n is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta minus tau sine 2 theta. But as tau is not there, so this becomes 0. So now substitute value sigma n equal to sigma x we have positive 150. Sigma y we have negative minus 75 upon 2 plus 150. Sigma y is minus becomes plus upon 2 cos 60. And to solve this, I got value of sigma n that is 93.75. So I have calculated separately. I got 37.5 plus 56.25. And this value I got equal to 93.75 Newton per mm square. And then find sigma t. So we have sigma t, this is equal to sigma x minus sigma y by 2 sine 2 theta plus tau cos 2 theta. But tau we have 0. So this becomes 0. And then we have equal to sigma x is 175, sigma y minus 75. So minus becomes plus. Sorry, this is 150. 150 minus of minus 75 upon 2 sine 60. Solve this. I got this value sigma t 97.43. And then from this find sigma r, which is equal to root of sigma n square plus sigma t square. And that is equal to root of sigma n we have 93.75 square plus 97.43 square. I got this value sigma r 135.21 Newton per mm square. Then we have asked maximum shear stress. So tau max Pn1 minus Pn2 upon 2. Now we have Pn1 150 because these are principal stresses. minus of minus 75 upon 2. And from this we will get value 112.5 Newton per mm square. So these are the values. Now you can write sigma R 135.21 Newton per mm square. Tau max 112.5 Newton per mm square. And then find angle of this. So we can have this tan of theta of resultant equal to sigma t upon sigma n. You can see in Moore's circle, you have to solve by Moore's. So sigma t I have 97.43 upon 93.75. And we will get angle of inclination with horizontal, that is equal to tan inverse 97.43 divided by 93.75. So it comes 46.10 degrees. This will be direction. This was first problem. Then we have another problem at a certain point in an elastic material. Normal stresses are, again we have given. So I will plot it. So we have given 90 MPa tensile. So we have this as 90 MPa. What? 90 MPa. And then we have 70 MPa compression. And we have to find value of tau. Now we have simple formula. Pn1 is given. Pn1 is equal to sigma x plus sigma y by 2 plus root of sigma x minus sigma y by 2 whole square plus tau square. Now sigma x we have 90 plus sigma y. Now this you can see compression. So we have this will be minus 70 by 2 plus root of 90 minus plus 70 by 2 whole square plus tau square. And this value is given 125. So we have this as 125. This is equal to 10 plus root of 90, 70, 160 by 2, 80 square plus tau square. Now this 10 we will take on this side, minus 10, and that is equal to root of 80 square plus tau square. Now this will be 115, which is equal to root of 6400 plus tau square. From this, we will squaring both these sides. 115 square equal to 6400 plus tau square. And from this, we will get tau is equal to root of 115 square minus 6400. And I got this value of tau, and that is equal to 82.61 Newton per mm square. So we have value of tau. So to what shearing stress may be subjected to on the given planes, and what will be the maximum shear stress. So tau we got 82.61. Now we have Pn2. Pn2. So we have sigma x plus sigma y by 2 And this becomes minus root of sigma x minus sigma y by 2 whole square plus tau square. And now Pn2 is equal to, we got this value 10, already we have calculated, minus root of, now first value we have 6400, plus we have 82.61 square. Now if you will solve this, you will get Pn2 is equal to 10 minus, I got this value 115. And from this we got, and therefore Pn2 is equal to minus 105 Newton per mm square. That is compression. So we have 105 Newton per mm square. That is compression. And then we have tau max, which is equal to Pn1 minus Pn2 upon 2. Now Pn1 we have 125. So we have 125 minus of minus 115 upon 2. And we will have this value that is equal to tau max. Sorry, 105. And from this we will get 130, 230. So 115 Newton per mm square. And therefore we have answers for this. So answer of tau we have. Tau is equal to 82.61 Newton per mm square. And tau max 115 Newton per mm square. Solve it by graphical it is difficult actually. So solve it by analytical and check your answers. So now we will stop here only. Thank you.